Tamper-resistant receptacles, often abbreviated TR receptacles, and ground fault circuit interrupters, known as GFCIs, serve different but related purposes in electrical safety. In pediatric areas, the National Electrical Code, or NEC, has specific requirements for TR receptacles. Some argue that GFCIs are an acceptable substitute. Let's delve into the distinctions and evaluate these claims. Firstly, consider the detection method. TR receptacles use mechanical shutters. These shutters block access to the electrical slots unless a proper plug is inserted. GFCIs, on the other hand, are electronic devices. They constantly monitor the balance of electrical current flowing between the hot and neutral conductors. If there is a significant imbalance, indicating a potential ground fault, the GFCI trips, cutting off power. Secondly, look at fault protection. TR receptacles are primarily designed to prevent accidental contact with live electrical terminals. GFCIs are designed to protect against ground faults. A ground fault happens when electrical current escapes its intended path and flows through an unintended conductor, like a person's body, to ground. The NEC Article 517 outlines requirements for healthcare facilities. It specifically mandates the use of listed TR receptacles in pediatric areas. It makes no mention of substituting GFCIs for TR receptacles. There are a few arguments in favor of equivalence. Firstly, GFCIs detect ground faults. Because ground faults are a common cause of electrical accidents, it's argued that GFCIs provide a higher level of protection than TR receptacles. Secondly, GFCIs can be seen as more reliable. Mechanical TR receptacles can fail over time due to wear and tear. GFCIs are typically more reliable, and many models include self-testing features. However, there are strong arguments against the equivalence of GFCIs and TR receptacles in pediatric settings. Firstly, TR receptacles physically prevent accidental contact with live terminals. GFCIs only react after contact has occurred and a current imbalance is detected. Secondly, GFCIs may not protect against all scenarios involving child exploration. If a child touches a live terminal but doesn't create a sufficient current imbalance to ground, the GFCI may not trip. For example, if a child isn't well grounded, the leakage current might not reach the GFCI's threshold. Thirdly, the NEC does not allow substitution. The NEC explicitly requires TR receptacles for pediatric areas, without providing exceptions for GFCIs. The NEC is the generally adopted safety benchmark for electrical installations. Therefore, TR receptacles and GFCIs are not equivalent, especially in pediatric areas. TR receptacles offer a higher level of protection by physically preventing accidental contact with live terminals. This preventative measure is particularly crucial in environments where young children are prone to exploring and experimenting with electrical devices. To elaborate on TR receptacles, they contain spring-loaded shutters inside the receptacle that block the slots. These shutters only open when both prongs of a standard plug are inserted simultaneously, ensuring that a child cannot insert a single object, like a paperclip or a toy, into the receptacle and receive an electrical shock. The design is simple but effective in preventing many common accidents. As for GFCIs, they work by monitoring the current flowing to and from an electrical device. The device measures the current balance between the hot and neutral wires. Under normal circumstances, the current flowing through these wires should be virtually identical. If a difference of 5 mA or 5 amps or more is detected, the GFCI trips, quickly cutting off the power to prevent electrical shock. This tripping happens very fast, typically within a fraction of a second. To better understand how GFCIs work, consider a scenario where someone is using a power drill. If the drill's wiring becomes frayed and comes into contact with the drill's metal casing, and the person touches the casing while also touching a grounded object, like a water pipe, electricity will flow through their body to the ground. A GFCI would detect this imbalance in current and quickly cut off the power, preventing a serious electrical shock. However, GFCIs are not foolproof. As mentioned earlier, if the current flowing through a person's body is less than 5 mA, the GFCI might not trip. This could happen if the person has very dry skin or is wearing insulating shoes, which would limit the flow of current to the ground. Furthermore, GFCIs only protect against ground faults. They do not protect against other types of electrical hazards, such as short circuits or overloads. Another type of protective device, a circuit breaker, provides that protection. Circuit breakers are designed to protect electrical circuits from overcurrents, which can be caused by short circuits or overloads. When the current in a circuit exceeds the breaker's rating, the breaker trips, cutting off the power to the circuit. Circuit breakers are typically rated in amps, such as 15 amps, 20 amps, or 30 amps. For example, a 15-amp circuit breaker is designed to protect a circuit that is wired with 14 American wire gauge, or OG, copper wire, while a 20-amp circuit breaker is designed to protect a circuit that is wired with 12 AWD copper wire. Using a circuit breaker with a higher rating than the wire is designed for can be dangerous, as it can allow the wire to overheat and potentially cause a fire. Now let's consider the NEC in more detail. The NEC is a comprehensive set of standards for safe electrical installations. It is updated every 3 years to reflect the latest advances in electrical technology and safety practices. The NEC is not law itself. Instead, it is a model code that is adopted by state and local jurisdictions. Article 517 of the NEC covers the requirements for healthcare facilities, including hospitals, nursing homes, and clinics. This article addresses a wide range of electrical safety issues, such as the need for emergency power systems, the grounding of electrical equipment, and the use of isolated power systems in critical care areas. Section 517.16 specifically addresses receptacles in patient care areas. This section requires that all receptacles in patient care areas be listed hospital-grade receptacles. Hospital-grade receptacles are designed to withstand the rigors of a healthcare environment. They have a stronger grip on plugs to prevent accidental disconnections, and they are tested to ensure that they can withstand repeated use and cleaning. The NEC also requires that all receptacles in pediatric locations be tamper-resistant. As previously mentioned, TR receptacles have internal shutters that prevent children from inserting objects into the slots. The combination of hospital-grade and tamper-resistant features ensures a high level of safety in these vulnerable environments. It's important to note that while GFCIs are widely used in healthcare facilities, particularly in wet locations such as bathrooms and near sinks, they are not a substitute for TR receptacles in pediatric areas. The NEC requirements are very specific in this regard, and the use of TR receptacles is essential for preventing electrical accidents involving children. Furthermore, the NEC contains numerous tables that provide guidance on the proper selection and installation of electrical equipment. For example, Table 310.16 provides ampacity ratings for various sizes of conductors based on their insulation type and the ambient temperature. This table is essential for ensuring that conductors are not overloaded, which could lead to overheating and fire. Table 250.122 provides minimum equipment grounding conductor sizes for various circuit breaker ratings. This table is crucial for ensuring that electrical equipment is properly grounded, which helps to prevent electrical shock hazards. These tables, along with the many other provisions in the NEC, are essential tools for electrical professionals. Adhering to these standards is critical for ensuring the safety of electrical installations in all types of buildings, especially in healthcare facilities where vulnerable patients are present. Another point to consider is the potential for human error. Electrical systems are complex, and even experienced electricians can make mistakes. That's why it's so important to have multiple layers of protection. TR receptacles provide a passive layer of protection that doesn't rely on human intervention. They are always working to prevent accidental contact with live terminals. GFCIs provide an active layer of protection that trips when a ground fault is detected. This active protection is essential, but it's not a substitute for the passive protection provided by TR receptacles. Regular inspections and testing of electrical systems are also essential for ensuring safety. Healthcare facilities should have a comprehensive electrical safety program that includes regular inspections of receptacles, circuit breakers, and other electrical equipment. These inspections should be performed by qualified electrical professionals who are familiar with the NEC requirements for healthcare facilities. In addition to inspections, regular testing of GFCIs is also important. GFCIs should be tested monthly to ensure that they are functioning properly. This can be done by pressing the test button on the GFCI. If the GFCI trips when the test button is pressed, it is working properly. If it doesn't trip, it should be replaced immediately. In summary, TR receptacles and GFCIs are both important safety devices, but they serve different purposes. TR receptacles prevent accidental contact with live terminals, while GFCIs protect against ground faults. The NEC requires TR receptacles in pediatric areas, and GFCIs are not an acceptable substitute. Healthcare facilities should have a comprehensive electrical safety program that includes regular inspections and testing of electrical equipment. TR receptacles provide a crucial layer of passive protection in these environments, preventing accidental contact with live terminals and ensuring the safety of young children. The importance of following the NEC cannot be overstated. It provides a baseline for electrical safety. Deviation from these standards can increase the risk of electrical shock, fire, and other hazards. In healthcare facilities where vulnerable patients are present, adherence to the NEC is particularly critical. Another aspect that is important in this context is the training and qualification of electrical personnel. Only qualified and experienced electricians should be allowed to work on electrical systems in healthcare facilities. These electricians should be thoroughly familiar with the NEC requirements for healthcare facilities, as well as with the specific electrical systems in the facility. Regular training and continuing education are essential for keeping electrical personnel up to date on the latest electrical safety practices and technologies. This commitment to training and qualification helps to minimize the risk of human error and ensures that electrical work is performed safely and correctly. In conclusion, the debate over TR receptacles versus GFCIs in pediatric areas boils down to our fundamental understanding of their respective functions and the specific requirements of the NEC. TR receptacles provide a physical barrier against accidental contact with live terminals, while GFCIs protect against ground faults. While both devices contribute to electrical safety, they are not interchangeable, especially in pediatric environments where the risk of electrical accidents involving children is a significant concern. The NEC mandates the use of TR receptacles in these areas, and this requirement should be strictly followed to ensure the safety of young patients. Furthermore, a comprehensive electrical safety program, including regular inspections, testing, and training of electrical personnel, is essential for maintaining a safe electrical environment in healthcare facilities. By adhering to these best practices, healthcare facilities can minimize the risk of electrical accidents and protect their patients from harm.